Hi, so we're on to topic 3. This is about Bitcoin, the blockchain, and Bitcoin, the cryptocurrency. Capital B for the blockchain, small b for the cryptocurrency. There are 2 parts. This first video covers the blockchain, and the second video covers the stages in a transaction of Bitcoin, the cryptocurrency. So in this video, I'm going to cover the different types of nodes and the roles they play in the network, second layer solutions, or also called second layer protocols, which are on top of the basic blockchain and turns it into something that can run smart contracts, and also other protocols that allow transactions to be off the blockchain. And finally, forks. These are changes to the protocol, and there are 2 types. We'll talk about the effect they have on the nodes and the network, and then finish the video. So a node is any computer that connects directly with the network, and different blockchains have different nodes. In the Bitcoin blockchain, there are basically 5 main types of nodes: light nodes, master nodes, full nodes, mining nodes, and lightning nodes. And if you want to learn more about them, this link will take you to a good article. So light nodes, also called thin nodes, are special wallets attached to a full node. An alternative name is SPV node, or Simplified Payment Verification, which explains what they do. They can send and receive transactions, but the main purpose is to confirm the validity of a block. When a miner says, here's a block, they quickly look up all the transactions in the block and check for no double spend. They only store a small amount of information, what we call the block headers, and we'll find out more about what block headers are in the next video. So there's much less storage requirement, but they do need to connect to a full node and trust that the information they get is correct. Master nodes are also called supernodes or listening nodes, and these have greater bandwidth and faster processing speed than a normal full node. It's because the firewalls that nodes have, all computers have firewalls nowadays, that will limit the speed of connection to other computers. So master nodes are really big computers. Basically, they're a sort of highly connected relay station for blockchain data. And a master node will have many full nodes, and the full nodes will have light nodes, okay? They should be on 24/7 so that they can relay information. So when you have a look at the map of these full nodes, you can see they're firing information across the world, and the map usually looks about the same, whatever time of day you look at it. Full nodes are the nodes that run the client software, Bitcoin Core. And if you want to download it, just click on that link and then you can see what it's like to install. They keep a copy of the entire blockchain, so you need a lot of memory in order to be a full node. And the main purpose is to apply the public key to verify transactions, to make sure that the sender and the output wallet addresses are bona fide, and particularly look up the sender's UTXO on the blockchain. And with the help of the light nodes, they will check the transaction for no double spend and punish any attempt to double spend by banning that node from the network. And once they've validated the transactions, they put them into something called the mem pool, or the memory pool. And here you can see some graphs of the growth over the last year of UTXOs in the network and the memory pool transaction count. So there was a lot of activity going up to, on average per day, 25,000 transactions in the memory pool. But normal level, apart from these peaks, is around 10 to 15,000. And the UTXO is growing. This is the total number of of valid ones, but it's not the amount of Bitcoin. It's you could have 50 Bitcoin in one UTXO or more. We've seen in the Bit Bonkers that some of those balls were really big, with thousands of Bitcoin in the transactions. So that would just be one UTXO, okay? So mining nodes are the full nodes which are able to add blocks to the chain. They build the chain, and they require some very specialized machines, ASIC, application-specific integrated circuit machines. And these machines, they get updated periodically. So if you bought one a year or two ago, it's not going to be powerful enough to compete with the latest ASIC miner 8 nano 58 terahertz per second. So it's quite expensive to run these mining nodes, in particular because the competition is so great. They've grown into not just a single machine, but they have massive warehouses called mining farms. We'll get onto that in a minute. So they need to control temperature, the fan speed, the hash rate. So there's all sorts of software you need to control that. Now, they build a block by forming something called a Merkle tree. M-E-R-K-L-E, not E-L as in the German Chancellor. They pick transactions out of the memory pool, particularly those that have got high fees, because if they win the proof of work puzzle, then they get the fees in the block, the sum of all the fees over all transactions in the block, plus something called the mining reward, which is currently 6.25 Bitcoin. So this reward, which halves approximately every 4 years, it halves every 210,000 blocks. Not quite sure why 210,000, but there we are. So it started off at 50 Bitcoin in the very first transaction sent from Satoshi Nakamoto to Hal Finney. 4 years later, approximately, it halved to 25, and in 2016, it went to 12.5. And just recently, this year in May, it halved again to 6.25 Bitcoin. So the calculations halving every 4 years means that by 21,036, when we're all dead and gone, if it still exists, the reward will be just 42 Satoshis. Satoshis is a tiny amount of Bitcoin. There are 10 to the power 8 Satoshis in one Bitcoin. So this way, the total number of Bitcoin is not expected to exceed 21 million. That's why it's not a fiat currency. At the moment, though, there's about 900 Bitcoin that are mined every day, because it takes about 10 minutes to build each block, and each block gets 6.25 Bitcoin. Having a look at some more blockchain statistics, we can see there's around 2,000 transactions per block. Fees have been very high lately, about $4 per transaction. And the transactions are getting larger. The average block size is about 1.25 megabyte. And the miner's revenue is falling, mainly because the reward halved on the 11th of May. So there's a lot of competition for the mining reward and the fees. And that's why these large mining farms are built. If you look closely at this picture, you'll see this thousands of computers, of ASIC machines are connected together. And of course, they consume a massive amount of electricity. And the problem just gets worse over time because the hash rate tells us that more and more ASIC machines are being connected to the network. And more powerful ones, that the hash rate is the total number of hashes. We'll talk about that more in the next video, exactly what a hash is. So the difficulty of this problem, again, in the next video, we'll go into the hash and the difficulty and how they're related in more detail. But the more difficult problem they have to solve is by trial and error, hashing and hashing and hashing, the more electricity they consume. So now the total network consumption of electricity is more than Iceland, it's more than Denmark, it's more than most of Africa, most countries in Africa. So yeah, there is a problem. It's not ecologically sound. Farms then gather into mining pools, which are conglomerates of farms, and most of them are in China, mostly in the north, where it's much cooler and it doesn't cost so much to cool these machines. So those statistics here analysing the network show that these F2 pool via BTC, slush pool, btc.com, btc.top, ant pool, poolin, they're all in China, and they have others. It's also about 20%, but about 80% now is in China. And so if the winning miner happens to be one of the farms in the mining pool, then they share the reward amongst them. It's a, as I said, it's a collaboration between different farms. Now, one of the problems with this network is if it takes 10 minutes to build a block, how are you going to buy a cup of coffee with Bitcoin? First of all, the coffee would be cold because it'll be at least 10 minutes and probably more like an hour before your transaction is confirmed. And if you haven't put a transaction fee in the UTXO that you put in with your UTXO, then it's going to wait a long time in the memory pool before it's taken in a block. So small transactions are very, very slow to confirm. So this is called the scalability problem. How do we scale up the network so it can deal with small payments? If you want to know more, Hacker Noon has a nice article here about the race for Visa-like transaction speed, so that, that using Bitcoin, which you can actually have on cryptocurrency cards now, but it becomes a much faster process. So one solution is to set up a payment channel. The idea of a payment channel is that only the open and close of the channel is recorded on the blockchain, and all the interim transactions are not. So you put maybe $100 in a channel, and the other end of the channel is your coffee shop, and then every day when you go in to buy coffee, you just tap, and it's one of the transactions that is credited on the channel. Okay, so this reduces the load on the main blockchain and speeds up the transfer of funds. And you don't have to add transaction fees as well. So this is a diagram of the Lightning Network, which is the network of payment channels on Bitcoin. Let me take another look at it now. Where are we? We're in the morning in the UK, so there'll be more connectivity around Europe. Later on, you'll see more of the channels being active in the US. So let me have a look at Sagittarius. That has 341. It's a node that has Lightning node with 341 other Lightning nodes connected to it, and payment channels going to all of those nodes. Coingate. This one has 868 channels. Let's see where it is. Looks like it's somewhere like Germany. Or, yeah, Germany, maybe Czechoslovakia. Rompert. Oh, that's obviously in the States, but it's connecting to a lot in Europe. Rompert has got over 1,000. Whoa, that's a big one. And there's some called BitMEX Research, which used to be in London, and that has 623. It's supposed to be for research, but one questions why they're connecting to Cape Town. Could be, but maybe, who knows? It's completely obscure. There's no record on the blockchain of the funds that are going on these channels. Maybe you set up a channel with a little bit of money for transmission of information off the chain for research, or maybe you're doing it with a lot of money and using it to transfer funds, which may not be legal, particularly in the US, because a lot of banks and hedge funds and so forth are not allowed to operate on some of the unregulated Bitcoin exchanges. We'll talk about that much later. Topic 6 or 7, I think it's 6. Okay. Anyway, so there's a very nice video from 99 Bitcoins, which I'm not going to go through because it's quite long.
What is the Lightning Network? Can I really send Bitcoins to anyone instantly without any fees? How does it even work? Well, stick around. In today's episode of Bitcoin Whiteboard Tuesday, we'll answer these questions and more.
Okay, so I'm not going to go through that because it's 7 minutes. You can watch it if you're interested in the Lightning Network. And there's another link here, which is from Decentralized Thought.
You may have seen something about Bitcoin a few years back. It sounded revolutionary. This is even longer, 9 minutes, but this chap, Decentralized Thought, that's a play on deep thought. If you know about Watergate and Nixon, that scandal, the character called Deep Thought was the informant about all the crime that was going on behind the scenes. And that's what this guy's trying to do. Quite interesting. So these large hubs in the network, he believes that they are banks that are undermining the whole philosophy of the Bitcoin network. If you remember from the very first lecture, the Genesis block, Satoshi Nakamoto coded Chancellor on brink of bailout to UK banks, second bailout. And that's because he disagreed with the entire financial system and banks in particular. So there are other second layer protocols. The Omni layer is an important one. So this allows programs like smart contracts to be recorded on Bitcoin. We'll find out much more about smart contracts in the next topic. Also, new tokens can be issued on the Bitcoin network using the Omni layer. Tether was one of the first tokens to use the Omni layer. Now it uses 8 different blockchains, which makes it a lot more difficult to keep track of where the tether is being issued and where it's going to. And these tokens can be traded on decentralized exchanges on the Omni layer. And we'll talk more about that. As I said, I'm going to be talking about exchanges in topic 6. I think. Could be 5. I think it's 6. Anyway. And there are other second layer protocols you can find out about: the Liquid Network, Simple Layer Protocol, SLPs, Plasma and Stellar Network. And again, there are links to more information about the Omni layer and the second layer protocol in your lecture notes. Finally, we're going to talk about forks. There are 2 types of forks: hard forks and soft forks. A hard fork is a change to the network rules that require a new client software to be downloaded. So a change in the level of difficulty or the way it's calculated,
transition to a new consensus algorithm, that's a major change. Implementation of new master nodes as well. Just a new block reward, for example, the 6.25, the halving recently required a new client software to be downloaded by all the full nodes. Nodes willing to do that carry on with the blockchain, but any node that carries on using the old client software is going to be rejected now. And this has happened in the past where there's been disputes about changes in protocol. And that's why we have these coins called Bitcoin Cash or Bitcoin Gold, because the network disagreed with the developers' suggestion for change, and they carried on running the old client code. It becomes a new, an old blockchain, but it's divorced from the new one. And soft forks are the other type of fork. And here it's not necessary to download a new client software. You can, but you don't need to. You can carry on and still be part of the network if you still have the old client software. And this is for smaller changes. For example, implementing pay-to-public key hash, which we'll talk about in the next video, or the segregated witness, which was a new function that allowed a sort of segregation of all the transactions from the block headers, so that it required less storage capacity for running the network and speeded things up. But this is still backwards compatible. When you download a new client, it's not, it's like new versions of Windows. They're still compatible with the older version. Okay, so that's it for this video, and I'll see you in the next.